Alright, so today we are going through 2H, that is derivatives of trigonometric functions. So we've got summary of the rules at the top, and then we've got 4 examples we're going to go through. So if you differentiate sin x, it goes to cos x. If you differentiate cos x, it goes to negative sin x. So they're cyclic, and then we've got the derivative of tan x. Then on the right hand side we have derivatives of composite functions. So we'll deal with them as we approach them, but let's get straight into this one. We can differentiate this in one step. Everything's up there as a power of n, ready for us to differentiate. The derivative of x squared, 2x. That 2 is just going to hang out the front of the sign, all right? And then the question I'm asking is, what's the derivative of sin x? The derivative of sin x is cos x, okay? And so perfectly suitable to write it like that. That's going to be our answer. Just differentiating term by term. All right, on to the next one. We have ln of 3x squared multiplied by sine of the square root of x. So ln of 3x squared times sine of the square root of x. That's going to be the product rule. So u, our first term, ln of 3x squared, v, our second term, sine of the square root of x. I'm going to express it straight away as x to the half. So for u dash then, that's what we were doing last lesson, where we were differentiating logarithmic functions. Now, let's just talk about that. That's going to be a good discussion point. I've got ln of 3x squared here. Is it equal to 2 ln of 3x? There's a temptation to say yes. The reason it's not is because that square only belongs to the x term. All right, whenever it's written like this, it only belongs to the x term. It's only if it's in brackets that it belongs to both 3 and the x. All right, so like this, 3x squared, it would, but if without the brackets, that tells us it only belongs to the term for which it is written directly above. So no, we can't do that. So we will leave it as it is, and we're just differentiating it accordingly. So when you have ln of f of x, the derivative is going to be f dash of x on top of f of x. All right. So the derivative of 3x squared is 6x, and then we have the 3x squared at the bottom. That can be simplified. You've got x's at the top, x's at the bottom. I'm just going to leave it because it says differentiate without simplifying. Okay, let's move on to the v dash then. This is where we're learning the skills today. We have a composite trig function because it's sine of some function of x. And so we're looking at the first rule on the right side. Sine of f of x goes to f dash of x times cos of f of x. So when we differentiate x to the half, we'll have half x to the minus half, and then cos of f of x. Alright, so we've differentiated x to the half, there it is there, and then times cos of f of x. Alright, smash them together. F dash of x equals u dash v plus u v dash. Very good. On to C. We have cos of ln of x. So it's cos of some function of x. So that's going to be the second rule on the right. Cos of f of x goes to negative f dash of x sine of f of x. So if we're focusing on the interior part, ln of x, when we differentiate ln of x, we get 1 on x. So dy dx is going to be minus 1 on x, okay? Negative f dash of x multiplied by sine of f of x. Now, with the one I've just done and with this one here, I've seen some people in the past like use the product rule. They've looked at that and they've gone, oh yeah, that's tan times e to the x. And that's wrong because tan is not a value, it's not a function. You have to have tan of something. All right. Similarly, it'd be like if you had square root of e to the x, and you were to say, oh, that's square root times by e to the x. All right. It has to be the square root of something. It has to be tan of something. It has to be ln of something. It's a function. All right. So we're not going to use the product rule here. We've just got tan of a function, and so that's our bottom rule on the right side. Tan of f of x, the derivative is going to be the derivative of e to the x on top of cos squared of e to the x. And so I might just talk about that notation that I've used at the bottom. So if we have cos of x squared, the correct way to write it is it's cos squared of x. All right, just so you're aware, that's what that means. It's not that you have the cos part squared and the x isn't. The whole thing is squared. Okay, so that is derivatives of trigonometric functions, 2h. Let's get into that exercise. Hopefully we're feeling okay about it.